All right, problem 11. It says without evaluating derivatives, which of the functions f of x equals ln of x, g of x equals ln of 13x, h of x equals ln of x squared, and px equals 3x squared have the same derivative? Unless you've done a lot of natural log derivatives, you will probably need to do the derivatives, but I will kind of explain that here. So let's look at the first two. Let's say f of x equals ln of x. And then I'm just going to say g of x equals, I'm going to say ln of ax. I'm just going to put a random constant there. Whenever we do the derivative of natural log, it's 1 over the argument times the derivative of the argument. So the derivative of x is 1. So 1 times 1 over x is just 1 over x. When we do the derivative of ln of ax in this case, we would get 1 divided by ax times the derivative of ax. Now, if we think about this as a power, it's 1 times the constant, which will just be a, and you subtract 1, and so that x goes away. And what happens is this constant cancels out the constant, and you still end up with 1 over x. So whenever you do the derivative of natural log, if it only differs by a multiple and the variable is the same, you will get the same derivative. So the same thing would happen with the h of x and the p of x. The x squared and the x squared match. They differ by a multiple, a numerical multiple. You can say a constant almost. And so f of x and g of x will be the same, as well as h of x and p of x. They would also be the same. All right, number 12. It says, by visual inspection, locate all points on the graph at which the slope of the tangent line equals the average rate of change over the interval -4 to 4. Okay, so we're going to kind of look at this. So from -4, if I was to draw a line connecting the dots, it would be a positive slope. Okay, positive slope. So I'm looking for lines that would be parallel, positive slope. So maybe somewhere along this line, not this section because it's going negative, and then maybe somewhere along this line. So maybe there's 2 points that would give me that positive slope, and so I'm going to look at the graphs and find something that's close to that. So if we look at A, it gives 3 points. So if I do tangent line at this point, maybe, definitely not this one because it's going the wrong direction, and we're going from -4 at this point to +4. So going left to right. So I would eliminate this graph. I would eliminate B because this point isn't even on the graph. We can look at C. Okay, it gives these 2 endpoints. Maybe tangent line there. This tangent line would be, I think, a little bit steeper. It seems like those 2 are a lot steeper than the line we're looking at. And so if we look at D, maybe these are closer because this is going up this way. This line is starting to flatten out, so it's not nearly as steep. It could be parallel to that same direction. And then this line is going down and then starting to curve, but it's like barely in that curve. It's kind of flat. So it looks like it's starting to go up that way, just past. So maybe by visual inspection, the best one looks to be D.